Hello everybody, welcome to this introductory video on stacks. This is Aparna presenting you the video on Introduction to Stacks. Starting with what are the topics to be covered in this video. The first topic is Introduction to Stack Data Structure and the second topic is Stack Operations. What are the learning objectives of this video? After viewing this video, one should be able to understand what a stack data structure is and learn how to implement different stack operations. So starting with considering a general stack, so we can see different stacks here. This is a pile of books and this is deck of cards, a stack of cookies and stack of chairs. In order to see a chair from this stack, which chair can be taken out first? Obviously the topmost chair. Similarly here, the first cookie that could be taken out is the topmost cookie. And here, the topmost card from this deck can be drawn conveniently and the topmost book from this pile can be taken out conveniently. So all these are classical examples of stacks. Now let us see what a stack is as a data structure. So stack is a linear data structure in which data can be added and removed from one end, that is called the top. Since the element that is inserted last is the element to be deleted first, stack is called a last in first out data structure, in short LIFO data structure. Let us consider an example stack. Here we can see a stack consisting of three elements initially 1, 7 and 2. Assume that we are inserting one more element to the stack by using push operation. So after pushing element 8 into the stack, the resulting stack would look like this. So 8 is there on the top of the stack. The remaining elements 1, 7 and 2 are same as earlier. Now again we are pushing second element into the stack. After pushing second element, that is 2, into the stack, the resulting stack looks like this. Then assume that we would like to delete an element from the stack. Since we know that insertions and deletions can be done only from the top of the stack, the first element that can be taken out of this stack will be at the position top. So the first element that gets deleted from this stack is 2. After deleting 2, the resulting stack would look like this. Now assume that we are once again applying pop operation on this stack. So the resulting stack would look like this. Then again, once again, a pop operation is applied on this stack, yielding a stack with two elements 7 and 2. Now let us see the basic operations that could be performed on a stack. Push and pop are considered as the basic operations for any stack. Push is for inserting a new element into the stack and pop is for removing an element from stack. In addition to these two basic operations, let us consider three more operations: peek, isEmpty and isFull. IsEmpty operation is for checking whether the stack is empty or not, and this operation is useful, while popping elements out of the stack. And isFull operation is for verifying whether the stack is full or not, and this operation is useful while pushing elements into the stack. And peek operation is for returning the topmost element out of the stack. So peek operation doesn't delete the topmost element, but it will simply return the value of topmost element of the stack. Starting with the peek operation, as I said earlier, peek operation doesn't delete an element from the stack, but it returns the topmost element of the stack. So before discussing the peek operation, let us make some assumptions here. Assume that we are implementing stack by using an array. So the stack we are considering is a fixed sized stack. And the programming language we are considering here is C. Now let us look at the implementation of peek operation in C. So this function implements peek operation. Since peek operation should return the topmost element of the stack, peek, the return type of peek is int. And this statement returns the topmost element. So we are storing all the elements. Since we are implementing stack using array, we are storing the elements of stack in an array called stack. Stack is the name of the array in which stack elements are being stored, and the topmost element is pointed by the index top. So stack of top points to the topmost element of the stack. So this return statement returns the topmost element of the stack. Now let us consider isFull and isEmpty operations. IsFull is for checking whether the stack is full or not, and isEmpty is for checking whether stack is empty or not. So what is the return type of isFull and isEmpty? The return type of isFull is Boolean and isEmpty is also Boolean. So isFull returns true if stack is full, and isEmpty returns true if stack is empty. Let us consider this example stack. Now assume that we are invoking isFull on this stack. So is this stack full? No. Here we can see two more slots that are vacant. So we can insert two more elements into this stack. So we are considering a stack of size 6. That is, we can place 6 elements in this stack. So isFull operation returns false for this stack. Now let us consider isEmpty. So isEmpty returns true if the stack is empty, and it returns false if the stack is not empty. Now for this example stack, isEmpty returns true or false. So it returns false since this stack has 4 elements in it. It is not empty. Now let us look at the implementation, C implementation of isFull and isEmpty operations in the form of isFull function and isEmpty function respectively. The return type of isFull is Boolean, and here we are checking if top is equal to maximum size. So top will become equivalent to maximum size whenever the stack has maximum size number of elements in it. So in that case, obviously the stack will be full. So the condition to be checked for verifying whether the stack is full or not is top equal to maximum size. So if this condition is true, means that the stack is full. So isFull function returns true. Otherwise, isFull function returns false. Now let us see the implementation of isEmpty. Since we are implementing stack using an array and the programming language we are considering here is C. In C, array index starts from 0. So whenever array is empty, that is the array that stores stack elements is empty, then the index of top will be -1. So top equal to -1 when there are no elements in the stack. So the condition to be checked for verifying whether the stack is empty or not is top equal to -1. So if this is true, then isEmpty returns true. Else isEmpty function returns false. Now let us consider push operation. Push operation is for inserting a new element into the stack. So I am considering this stack and inserting a new element 45 into this stack. So after inserting 45, the resulting stack would be like this. So what are the operations involved in push operation? So let us consider the steps involved in implementing push operation. The first step is we have to check if the stack is full. So if a stack is full, you cannot insert a new element into the stack. So the first step to be performed is to verify whether there is a room for inserting new element into the stack or not. So the step 1 is check if the stack is full. Step 2 is if stack is full, then produce error and exit. Step 3 is if stack is not full, increment top so that top points to the next empty slot where the new element can be placed. And fourth step is add data element to the stack location where top is pointing. So these 4 steps will perform a push operation, and this is the C program implementation of push operation. The return type, since push is not expected to return any value, the return type of push is void, and since push inserts a data element into the stack, push takes an argument whose data type is matched with the data type of elements in the stack. In this example, we are considering the stack elements are of type int. So here we are checking if stack is full or not by using isFull function. So if this is not true, if isFull is not true, then we can place a new element into the stack. So we are incrementing top, then we are placing the element at the top of the stack. Otherwise, that is if isFull is not false, then we cannot insert new element into the stack since stack is already full. So in that case, simply we are printing could not insert data, stack is full. The last operation we consider is pop operation. So I have a stack with 4 elements in it, and when I apply pop operation on this stack, the topmost element is 67 and that will get deleted from the stack. So after pop operation, the resulting stack would look like this. Now let us consider the sequence of steps to be considered for performing pop operation on a stack. The first step is